Hey guys, Jake here, coming at you with another math lesson. Today we're going to continue our discussion of rational functions. I've made a few videos recently about polynomials and rational functions. We're going to continue on that a bit, talking about asymptotes of rational functions, both vertical and horizontal. Before we jump into that though, be sure to go check out this link up here in the upper right hand corner of your screen, jakesmathlessons.com/precalculus-study-guide. Or scan this QR code. I've recently come out with a precalculus study guide. It's going to be a huge time saver to you. It's a really great study guide. It's really going to save you a lot of time and help boost your scores on your precalculus test. So if you are taking precalc, go check that out. You won't regret it, I promise. So anyway, let's go ahead and get into rational functions and asymptotes. So I talked a little bit in my video yesterday about rational functions. In general, this is the form of a rational function. Some function with some numerator and some denominator, so it does need to be the entire function being a fraction, basically, where the numerator of the function is a polynomial and the denominator of the function is a polynomial. So a polynomial is just a bunch of terms being added or subtracted together, where each term is just a constant number coefficient times x raised up to some positive whole number power. Or you may just have a constant coefficient times x, which still kind of has an implied positive whole number power of 1, or just a constant term by itself with no x. So just a bunch of those added and subtracted together gives you a polynomial. If you put a polynomial over another polynomial in a fraction, that gives you a rational function. So if you have a rational function, some numerator function and some denominator function, the top and the bottom of your fraction, you also need to make sure that the numerator and denominator function have no common factors. Okay, that's very important here. The no common factors piece is going to play a role with these asymptotes. There's a few rules that are going to make asymptotes a lot easier to find, as long as you make sure that you have a rational function with no common factors on the top and the bottom. If there's common factors and things would cancel out if you were to simplify the fraction, these rules that we're about to go into no longer apply. There's some other stuff you want to keep in mind, which I touched on a little bit on one of my recent videos, but I think that's probably a topic for another video in itself. So maybe I'll make another video about holes, which is kind of what they create. But when you have no common factors, you can easily figure out the asymptotes of this rational function by using a couple specific rules. So let's first talk about vertical asymptotes before we get into the horizontal. So vertical asymptotes are going to occur at the zeros of d of x, so the zeros of the denominator function. So basically, if you take the entire denominator of your fraction function and find the zeros of that polynomial, that's going to give you your vertical asymptotes, okay? So we will get into an example here in a bit, and I'll show you what I mean by this. But if you find the zeros, so basically take your entire denominator function, so if we take this whole thing, can't write apparently, b1x plus b0, take this whole thing, set it equal to 0, solve for x. Okay, whatever you get for x, for the solutions to this equation being equal to 0, those are going to be where you have vertical asymptotes. So at the end, you're going to end up with x equals some numbers, right? Could be 1, 2, 3 halves. I'm just saying random numbers, but you're going to get x equals some numbers, right? And those numbers is where you're going to have vertical asymptotes. So like I said, we'll go through an example and I'll show you kind of how to actually do that. But in general, if you can just take the bottom of your fraction, set it equal to 0, solve for x, that gives you your vertical asymptotes, okay? Pretty straightforward. Horizontal asymptotes are a little bit more involved though. So let's talk about those. So horizontal asymptotes, you have three cases basically. If you think about your rational function, where you have this numerator function, this denominator function, to figure out which of the three cases you're going to be looking at, all you want to do is take your leading term of your numerator function and your leading term of your denominator function. So in other words, what a leading term is, your highest powered x term. So in this case, you can see it's already ordered from the highest powered x down to the lowest powered x. But in general, theoretically, let's say we had some polynomial on the top of our fraction here that wasn't in order. So let's say we had like x plus 3 minus 3x squared, okay? You want to look for your highest powered x term. So right here, x squared, that's our highest powered x. We're going to take that entire term. So we're actually going to look at negative 3x squared as the term as a whole, which is going to come into play here. And then you want to do the same thing in the denominator. You want to get your highest powered x term in your denominator. In this case, we just have bm x to the n and an x to the n. But really, you're just taking your highest powered x term and comparing them to each other, okay? The comparison you're going to make is very simply looking at the power of your highest powered x term from the top and the bottom of your fraction, seeing if, you know, how they compare to each other. So in this case, we have our numerator is n, our denominator is m. Probably shouldn't have picked two letters that sound so similar, but n is numerator, so the top of our fraction. M is denominator, bottom of our fraction. So looking at these, we have three cases, right? The degree, the power of our highest powered x on the top of our fraction is less than the highest power x on the bottom of our fraction. So the degree of the top is less than the degree of the bottom. That's case one. That tells us we have a horizontal asymptote at y equals 0. We have one horizontal asymptote at y equals 0, okay? If the highest power x in our top of our fraction equals the highest power that we're raising x to in the bottom of our fraction, then we have a horizontal asymptote, which we can calculate using the coefficient of those x terms. So we would take the coefficient of the term on the top of our fraction divided by the coefficient of the term, the leading term on the bottom of our fraction. So let's say we have 3x squared minus 6 over 2x squared plus x. In this case, the highest powered x on the denominator is x squared. The highest powered x on the numerator is x squared also. So we're just going to take the coefficient of those x squared terms and put it over each other. So 3 over 2 is going to be where we have a horizontal asymptote when the degrees are the same. Okay? Then the third case is if the highest power x on the top of our fraction is bigger than the highest power x on the bottom of our fraction. In that case, we have no horizontal asymptotes. If you have a situation where the power of x on the top of your fraction is bigger than the highest power x on the bottom, that just means that your function is going to basically go off to infinity or negative infinity in either direction. So the end behavior is going to go off to infinity or negative infinity, and there's not going to be a horizontal asymptote. So those are the three cases. That's it. You really just have to look at the highest powered x term on the top, the highest powered x term on the bottom. First compare the powers, and that tells you which of these three categories you're in. If you end up with the powers being equal, you then take the coefficients and you use those to calculate where the actual horizontal asymptote is. So that's really all there is to it. Let's do a couple examples here. So we're going to find all horizontal and vertical asymptotes of the graph of each rational function. We'll start with this one here, f of x equals 2x squared all over x squared minus 1. Okay? So let's start with vertical asymptotes. Vertical asymptotes is finding the zeros of the denominator of our function. So we just take the denominator, x squared minus 1, set it equal to 0, solve for x. Okay? So to solve this equation, we would probably want to factor using difference of squares. So that tells us x minus 1 times x plus 1 equals 0. Okay? So that's how we would factor out the bottom. Just a quick check to make sure we can use these rules. The numerator is already factored out all the way, and there's no common factors between 2x squared and x minus 1 times x plus 1. If there was a common factor, then all bets would be off. We would have to ignore those rules we just went over. But in this case, we don't have to worry about that, okay? So no common factors, we can use these rules. Solving this, sitting this into these two kind of simpler equations from here, x minus 1 equals 0, x plus 1 equals 0, add 1 to both sides. Over here, we would subtract 1 from both sides. We get x equals 1, x equals negative 1. So we have, in this case, two vertical asymptotes. So vertical asymptotes at x equals 1 and x equals negative 1. We've got two of them. Okay? What about horizontal asymptotes? So remember, to find horizontal asymptotes, all we have to do is look at the highest powered x term in the numerator, the highest powered x term in the denominator. In this case, the highest power x term in the numerator is 2x squared. The highest power x term in the denominator is x squared. So notice the power of those is the same. They have the same highest powered x power, the same degree. They're both degree 2 polynomials, second degree polynomials. Okay? When the degree of the numerator and the denominator is equal, which of those three categories do we find ourselves in? If we go back up here and look at the horizontal asymptotes, when they're equal, that's category 2. So we know that we have a horizontal asymptote at the coefficient of the numerator term over the denominator term. So we just have to look at the coefficients now. Well, the coefficient of our numerator term is 2. The coefficient of our denominator term is 1. So if we just put 2 over 1 and then simplify that, that's just equal to 2. That tells us we have a horizontal asymptote at y equals 2. So notice the form of our answers here. Horizontal asymptotes are going to be horizontal lines. The equation of a horizontal line is y equals a number. A vertical asymptote is going to be a vertical line. The equation of a vertical line is x equals a number. So vertical asymptotes are going to be x equals something. Horizontal is going to be y equals something. So this is our horizontal asymptote. Okay, let's do another example. So first of all, we want to make sure that we have no common factors. So to do that, we need to start by factoring the top of our fraction and the bottom of our fraction, the numerator and the denominator. Okay, so factoring this numerator, we need a number that multiplies to negative 2, two numbers that multiply to negative 2 and add to positive 1. So that would be negative 1 and positive 2. So x plus 2, x minus 1. 2 times negative 1 is negative 2. 2 plus negative 1, or 2 minus 1, is positive 1. So that's how you'd factor that one. And then down here, we need two numbers that multiply to negative 6, add to negative 1. So we're going to get x minus 3, x plus 2. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. Okay, so they factor out this way. So now look what we have here. We got to be very careful here. Now we see that we actually have a common factor. So that's kind of a problem. They both have an x plus 2 factor in them, which means these rules that we discussed is not necessarily going to tell us where all of our vertical and horizontal asymptotes are. In fact, what this does tell us is that we have a hole at x equals negative 2. So the x value that would cause this factor that canceled to be 0, that's actually going to be a hole instead of a vertical asymptote. Okay? The other 0 of our denominator, x equals 3, whoops, not 1, but 3, that actually is going to be a vertical asymptote because it didn't cancel with anything on the numerator. So that's what's kind of weird here. We're actually going to end up with, in this case, since we had a canceling factor, this factor gives us a hole. The non-canceling factor actually does give us a vertical asymptote. But we can't just generally say all the zeros of our denominator give us a vertical asymptote, because if it cancels with the term on the numerator, that's not true. Okay. So the weird kind of thing about a function like this is, since we had that canceling term, we can't necessarily just say right away that the horizontal asymptote rules are going to work the same either. So we want to be very careful. Sometimes it may end up working the same, but it may not. So we want to be careful about that. let's think about what this function is going to do or behave like. Whenever you have a canceling factor like that, what that tells you is the original function that we started with is going to behave exactly the same as the simplified version. So if we cancel those x plus 2 terms, we end up with x minus 1 over x minus 3. This function is going to behave exactly the same as our original one, except for one key difference. It has a hole at x equals negative 2. So if we graph this function right here, and then just take out the point where x equals negative 2, take that point out and put a hole there, that's exactly what this function is going to look like. So if we can find a horizontal asymptote in this function, this one should have that same horizontal asymptote because it's going to be the same function except for one point is going to be different. So thinking about now the rules of horizontal asymptotes for this function, the highest power x in the numerator is x, the highest power x in the denominator is x. If we take those coefficients, since the power is equal to each other, take those coefficients, and we get 1 over 1, that just simplifies down to 1. That tells us we have a horizontal asymptote at y equals 1. So this is, again, another horizontal asymptote. And this function both would have that horizontal asymptote. If we plot this function, then just remove that one point, that tells us what this function is going to look like, which is going to leave us with a vertical asymptote at x equals 3. So kind of a lot going on there. Hopefully that makes sense. If you have any questions, throw them down in the comments. And be sure to go check out jakesmathlessons.com/precalculus-study-guide. And if you want to keep taking a little bit of a deeper dive into rational functions or zeros of polynomials, go check out that video up there. I'll put it over there somewhere. Go check that out, and I'll see you next time.